this one. This is the previous example that we took before. We said instead of using the straight chain, we are going to take this bending chain. Why? Because here we have the number of branches here is the more than this one and this one. That's why we choose this branch. Regarding to the name, we said that you are going to count the number of carbon atoms. Here we have 8 carbon atoms, and why we started from this carbon atom with the first one, with this. Regarding to, we are going to choose the closest carbon atoms to the branch, not away from it. Okay, so instead of saying 1, 2, 3, 4, and we have 4 methyl, we are going to say 2 methyl and so on. Okay, so you are going to choose the number, the arrangement or the order of the numbers regarding to the branch that you have. The closest number or the smallest number to the branch, so this is the right name. Okay, another example. Here we have CH3, CH, CH3, CH2, CH, CH3, CH, CH3, CH3. How can I name this alkane? First of all, you should choose the longest branch that you have, straight branch that you have, as we explained before. So, should I choose this one as a straight chain or bending like that, and I have here a branch? Oh, of course, the easiest way to use the straight chain. Why? Because this is the longest number of carbon atoms that you have. Count with me. 1, 2, 3, 4, 5, 6. Okay? And you have only one branch for 3 carbon atoms. Here we have CH3, CH3, CH3. So you don't have to bend the chain in front of you. Okay? So the straight chain here contains how many carbon atoms? 1, 2, 3, 4, 5, 6. And number 6 is hex. Okay? And we have alkane, so it's hexane. Hexane. Okay? Let's name the branched groups that we have, the alkyl groups here. We have here CH3, CH3, CH3. So we have 3 methyl groups. Okay? So we are going to say trimethyl, but I need to know the order of these branched methyl groups according to the numbers connected to the number of carbon atoms. Should I choose from here or from here? Okay, here we have how many branch? 2, and here we have 1. So you should choose the numbers, the order of number to name or the order of carbon atoms from here. So I have here 1, 2, 3, 4, 5, 6. And instead of saying 1, 2, 3, 4, 5, 6. Okay. So where is the methyl groups? In carbon atom number 2 and 3 and 4. Sorry, 5. Okay. So we have 2, 3, 5 trimethyl hexane. Again, 2, 3, 5 trimethyl hexane. Okay. So again, here we count the order of carbon atoms regarding to the continuous chain, so that the alkyl group have the lowest number possible. So the lowest number, we are going to start from these carbon atom, not from this one. Okay, because this one it will be the longest number of possible alkyl groups. Okay, here we have two examples. And yourself if you have any question. Okay, or you want to answer with me. Here we have the longest chain that we have, the straight one. How many carbon atoms? One, two, three, four. Meth, eighth, prop, put. So this is butane. Okay, and we only have one alkyl group, which is methyl here. So we have methyl butane. Should I put a number to methyl group? It doesn't matter. Why? Because you only have one branch. Okay. So I don't care if you put a number or not. If you want to say 2-methyl butane, it's okay. But in correct way, if you have one branch, say methyl butane directly without saying the numbers. When should I put the numbers? If you have more than one alkyl group or more than one branch. Okay, like the second example. Here, the longest chain that you have, 1, 2, 3, 4, 5, 6. Okay, hexane. Okay, then we have methyl and ethyl group. From where should I start the numbers? The order. From this carbon atom or from this carbon atom, and why? You can unmute yourself if you want to answer this question. Okay, guys, here the longest is chain. We have hexa, and I will start the order from this carbon atom. Why? Because the first ethyl group here nearest to this carbon atom. So I'm gonna choose the lowest possible number here because I will start with ethyl, then methyl. As we arrange these branched groups alphabetical order. So we are going to choose ethyl before methyl, as we said before. Okay, the ethyl group connected to the carbon atom, which is the third one. Here, one, two, three, and methyl connected with the fourth one. So we have three ethyl, four methyl, one, two, three, four, six, 5, 6 hexane. 3 ethyl, 4 methyl hexane. Do you have any question in this part? If you have, unmute yourself. Okay, let's move to now you can know how to name the alkanes. Let's talk about the properties and the uses of alkanes. Do you have any question? Okay, guys. Okay, properties of alkanes. We said before that alkanes means that all carbon atoms have four single covalent bonds. Okay, and by the way, the alkanes molecules are non-polar, so they are non-polar molecules. So you are not going to find even a positive partial charge or negative partial charge on it. And the only forces of attraction between nonpolar molecules are weak London dispersion force. So the London dispersion force is weak between the molecules of the alkanes. And the meaning of London dispersion force is the attraction force between the molecules, the intermolecular spaces between. You know that we have intermolecular spaces between the molecules, and there is attraction force that occurs between the electrons and the protons in the other molecule, and the electrons and the other molecules and the other protons in the other molecules as well. So there is a repulsion and attraction force between them. So they form something called temporary dipole. Okay, so they make like a partial charge and positive, negative charge and positive charge, partial. Okay, so you are going to see that there is attraction force between the molecules called London dispersion force. Okay, this London dispersion force is weak between the non-polar molecules, so it's weak between the alkanes molecules. Okay, but the London dispersion forces are stronger when the molecules are larger. So the physical states of alkanes are a function of their molecular size, depending on the number of carbon atoms that you have. So the physical state will differ from each other. Maybe if you increase the number of carbon atoms in the alkane, so you have a high melting point and high boiling point and so on. Okay. Let's talk about the state of matter that you have. If you have the alkane less than 4 or from 1 to 4 carbon, so you have meth, ethane, propane, and butane. All of these are gases. Okay, so the first four examples of alkanes are gases. Okay, the natural gas is a fossil fuel compound primarily of alkanes containing 1 to 4 carbon atoms. The natural gas, by the way. And the most common natural gas, we use it methane and propane and so on, and butane, by the way. Larger alkanes, such as gasoline and kerosene, are liquids. So gasoline and kerosene are liquids because they have larger than 4 carbon atoms. If you have a high molecular mass, high number of carbon atoms, so it will be solid like paraffin wax. Okay, so the physical state depends on the number of carbon atoms in alkanes. The boiling point, of course, when increasing the molecular mass, it's logic that if we increase in the carbon and the bonds between the carbon atoms, so you need a higher melting point, okay, or boiling point. Why? As we said before, because the force increases, the London dispersion forces increase, and more energy is required to pull the molecules apart. Okay? So by increasing the number of carbon atoms, the boiling point increases as well. And this property is used to separation of petroleum major sources of volcanoes. You know that petroleum is a complex mixture of different hydrocarbons. Okay, so how can we separate these components from each other? By their boiling point. Each component has its own boiling point. Okay, when it reaches the specific boiling point, it starts to change into a vapor or whatever. So you are going to extract it from the components of petroleum, the petroleum mixture. Look at this picture. Okay, guys, this is the petroleum mixture, and you are going to see that I have different boiling points here, starting from 20 degrees Celsius, then 70, 120, 170, 270, till 600 degrees Celsius. Okay, so when I put the petroleum mixture, they start to evaporate each components in a specific temperature. That's why we get the petroleum gas, the gasoline, the paraffin, kerosene, and so on by their boiling points. So they change it from liquid or into a gaseous state. Okay, and this, by the way, the picture that you showed before, called fractional distillation, which means components of a mixture are separated on the basis of boiling point by condensation of vapor in a fractioning column, as you saw before. Okay, let's talk about the second type of hydrocarbon, which are the alkanes. So we talk alkanes with A, and now we are going to talk about alkenes, E. Okay, what is the difference between them? We said that alkanes, they are saturated, okay, and each carbon atoms contains four single covalent bonds, okay, while the unsaturated hydrocarbons, or the first example of it, alkenes, they are unsaturated because they contains double covalent bond, okay, maybe one double covalent bond or more than one, okay, and this is the meaning of alkenes, okay. Then inshallah next time we're going to talk about alkynes. Alkynes contains one or more triple covalent bonds, okay. So now you know what do I mean by alkenes. Here, if I don't have this double bond between the two carbon atoms, I will say that this is ethane, okay, because it contains two carbon atoms, okay. Here we have a double bond, so instead of saying ethane, A, I will replace it with E, because it's now alkene, not alkane, okay. So with the same name, by the way, if you have two carbon atoms, so it will be ethene, ethene, okay. Here we have triple covalent bond, three bonds here, so it's called ethyne, related to or belong to alkynes, okay. Here we have double bond, so it's ene, not ine, okay. This is regarding to the difference between alkane, alkene, and alkyne. Okay, regarding to the names, from where should I start? You are going to start from the double bond had the lowest number of carbon atoms. So I have here a double bond, okay? And I have how many carbon atoms? One, two, three, four, five. So this is called pent. Should I say pentane with A or pentene with E? Pentane because I have a double bond. This is the difference between alkanes and alkenes. And here we have CH2, CH3, which is called ethyl group, started with number 2. So I have one pentane, two ethyl, and this is the name. But instead of saying 1 pentane and 2 ethyl, we said it as 2 ethyl 1 pentane. Okay, starting with the alkyl group first. So I have 2 ethyl and 1, because related to the double bond here, 1 pentane. Okay, this is regarding to the name. What is the difference between these two molecules? Here we have 3, and here we have 3 carbon atoms. So they are called propane, propene, propane, propane. Okay, ane. And by the way, the rule that we use it to count the number of carbon and hydrogen atoms in alkenes, CnH2n. In alkanes, if you remember that, so CnH2n plus 2. This is the difference between them. I think that's enough for today. If you have any question, ask before we leave.
No, no,
You can
no.
unmute yourself.
I don't think.
Sorry?
I'm this said.
Yes, you can leave.